Let's see sharing of charge. What is it? Let's understand the concept. When we have two bodies with charge, how it is shared in case of capacitors. Now, if you remember, in case of concentric spherical cells, that is spherical capacitor, the capacitance was 4 pi epsilon 0 by 1 by B minus 1 by A. No, sorry, 1 A was the inner radius. 1 by A minus 1 by B. This was the capacitance of a spherical capacitor. Now, if B is infinity, that is, you have one spherical cell, and this spherical cell, you don't have any considerable distance. It may be Earth. That is just a spherical charge which has charge distribution. So, if this is the case, this will be infinity. So, what you will get is 4 pi epsilon 0 and the radius, that is A. Okay. So, now let's see how charges are shared if two spherical cells are connected. Let's say this is a spherical cell with capacitance C1, charge is Q1, initial voltage is V1, and let's say its potential energy, electric potential energy is U1. Similarly, you have C2, Q2, V2, U2. I'm giving you the concept. So before these two are connected, obviously what will happen? When you will connect these two, there will be a flow of charge from higher potential to lower potential. So before this is connected, total charge will be total charge. This will be Q1 plus Q2. And what is Q1? Q1 will be C1 V1 plus C2 V2. Okay. What will be the initial charge total energy? U, it will be U1 plus U2. And what will be U1? Half C1 V1 square plus half C2 V2 square. Okay. And third relation we have C1, we can write it as 4 pi epsilon 0 R1 if the radius of this is R1 and this is R2. Then this is C1 is this and C2 is 4 pi epsilon 0 R2. Okay, before we connect the two spherical cells, this is the situation. Now let's say at this point we connect it. Therefore, whichever be the higher potential, from higher potential to lower potential, there will be a share of charge. That is, charge will flow from higher potential to lower potential till it becomes equal. That is, let's say the potential at equilibrium is V, capital V. So after the two are connected, total charge will be, let's say new charge is Q1 dash and Q2 dash. Now from conservation of charge, you know charge is conserved. So this will be equal to Q1 plus Q2. So this is the first relation you should keep in mind, that Q1 dash will be C1V. Q1 dash will be C1V and Q2 dash will be C2V because V is the new potential. And this will be equal to C1V1 plus C2V2. So from here you have a relation that V, the potential at equilibrium, will be equal to C1V1 plus C2V2 by C1 plus C2. Okay, this is one relation. Then let's see the second relation. Let's see some more relations. Second is, what will be Q1 dash by Q2 dash, the ratio. This you can write C1V by C2V, that is C1 by C2, and C1 you have seen 4 pi epsilon 0 R1 and C2 is 4 pi epsilon 0 R2, that is Q1 dash by Q2 dash is R1 by R2. Okay, this is your second relation. One thing you can do, add 1 to both sides. Sorry, this is equal to 1 plus R1 by R2. So this is Q1 dash plus Q2 dash by Q2 dash. This is equal to R1 plus R2 by R2. Okay, and Q1 plus Q2 dash is equal to Q1 plus Q2, that is equal to the total charge of the system Q. So you can write it like this, Q, that was Q1 plus Q2. So from here you have a relation which is useful. You'll need it when solving objective questions. So from here you can write Q2 dash is basically equal to R2 by R1 plus R2, that is the ratio. Q2 dash is R2 by into Q, that is total charge, this fraction of the total charge. Similarly, you can write Q1 dash will be undoubtedly equal to R1 plus R2 Q. So this you'll need when solving objective questions. Okay. One more relation that you'll require is, you saw what was initial electric potential energy. It was half C1 V1 square plus half C2 V2 square. What will be the final electric potential energy? Because the potential is V common to both. So half C1 V square plus half C2 V square, that is 1 by 2 C1 plus C2 V square. Okay. So if you want to know what is the difference of energy when we connected it, what is the difference of energy? It will be U initial minus U final. So that you can write half C1 V1 square plus half C2 V2 square minus half C1 plus C2 V square. Okay. So these are few relation between different variables that you can use when solving problems. Now see an example. Two conducting spheres of radius 6 cm and 12 cm each have same charge 3 into 10 to the power minus 8. That is, the total charge is 3 into 10 to the power minus 8 on first and 3 into 10 to the power minus 8 into 2. So 3 into 10 to the power minus 8 coulombs. That is 6 into 10 to the power minus 8 coulombs. This is the total charge. Okay. Now they are connected. The direction, we have to find the direction and amount of charge transferred. Let's first of all see what is the charge transferred. You know, new charge on Q1 will be R1 by R1 plus R2 into the total charge. This we have just seen. So this will be R1. Where is R1? R1 is, let's say this 6 is R1 and this is R2. So this will be 6 by 6 plus 12. Centimeter, it is the ratio into 6 into 10 to the power minus 8 coulombs. What is this? This will be 1 by 3. So 2. So Q1 dash will be 2 into 10 to the power minus 8 coulombs. That is, it has dropped from 3 into 10 to the power minus 8 to 2 into 10 to the power minus 8. That is to mean 1 into 10 to the power minus 8 coulombs has been transferred from Q1 to Q2. That is first ball to second. We'll analyze the direction with understanding of potential also. So Q1 dash is this. Okay, 2 into 10 to the power minus 8. What will be Q2? Obviously, it has dropped from 3 to 2. So the second one will gain 1 coulombs, 1 into 10 to the power minus 8 coulombs. So that it will be 3 plus 1, that is 4 into 10 to the power minus 8. Let's see. Q2 dash will be 12 by 6 plus 12 into 10 to the power minus 8 coulombs. So this is 18, this is 12. So 6 to 3. 2, this is 4 into 10 to the power minus 8. From conservation of charge only we concluded that since it has the charge on the first ball has dropped from 3 to 2, obviously the charge on the second ball will rise from 3 to 4. That is true. Now direction, obviously Q1, that is first ball to second ball. Also we know that charge flows from higher potential to lower potential, and V is inversely proportional to R. This you know. Since it is inversely proportional to R, therefore potential on the ball with lower radius will be high. Therefore, from ball of radius 6 cm to ball of radius 12 cm, this will be the direction of charge. That is first to second. Clear? Now second, final potential. What will be the final potential? Now we have just found Q1 dash equal to 2 into 10 to the power minus 8, and you know Q is what? C into V. Do we have C? No, we don't have C. So how to find? Okay, but Q by V is C, that is CV. So you can say this is C1 into new potential. What is C1? C1 is 4 pi epsilon 0 R1 V. So from here, what we do? We 2 into 10 to the power minus 8, 4 pi, then we have epsilon 0 and R1. R1 is 6, that is 6 into 10 to the power minus 2 meters. So let's find out. You should also calculate this. It comes to 3 kilovolts. Okay, you can find from Q2 dash also. Q2 dash is 4 into 10 to the power minus 8. That will be equal to 4 pi epsilon 0 R2, that is 12 R2 V. So here, if you calculate, that will also come to 3 kilovolts. So final potential is 3 kilovolts. See this question. It says a solid conducting sphere of radius r1 is enclosed by a thin metallic shell of radius r2. A charge q. A charge q is given on the inner sphere. On this we have a charge q. Okay. When the two are connected, find the heat generated in charge transfer. See, this is grounded, so potential is 0. So all charge that has been put on this inner sphere will get transferred to the outer sphere because this has 0 potential. What will be the heat generated? Heat generated will be the potential energy that this sphere possessed and the final potential energy. So change in potential energy will be will give the heat generated. What is initial potential energy? If you remember, for a sphere I had derived it, it was q square 4 pi epsilon 0 r, that is for this it is r1, and final same thing, q square 4 pi epsilon 0 r2. So the heat generated will be this. Heat generated will be change in energy, that is q square by 4 pi epsilon 0 1 by r1 minus 1 by r2. Okay, clear? See the question. It says two capacitors C1 and C2. The values are given 2 microfarads and 3 microfarads. These are charged to 20 volts and 10 volts respectively. Okay, so it is like this. Let's say this is your 2 microfarad capacitor. It is charged up to 20 volts. Okay, and then you have the second one, 3 microfarad capacitor. It is charged up to 10 volts. They are connected same polarity, that is like this. So we have to find final V. When these two are connected, obviously this is at 20 volts, so charge will flow from this to this because it is at higher potential. So at equilibrium there will be a voltage. Then we have to find charge on both capacitors. It's not given before or after, so we'll find both, and heat produced in transferring. Okay, picture is clear. So let's start. So what is, let's say Q1. Q1 will be C1 V1, and we are given with C1 is 2 microfarads into V1. V1 is 20 volts. So what you get is 40 microcoulombs. Okay, so Q1 is 40 microcoulombs. That is charge is stored in the first capacitor before it is connected is 40 microcoulombs. So let's write it here only. 40 microcoulombs. Now second one. Second charge will be C2 into V2. C2 is 3, this is 10. So we'll have 30 microcoulombs. Okay, so Q1 is this, Q2 is this. Now the two are connected. After connection, we'll have a potential. What will be that potential? That potential will be, from conservation of charge, C1 V1 plus C2 V2, that is Q1 plus Q2. This will be equal to now C1 V, let's say the new potential is V plus C2 V, that is Q2 dash plus, sorry, Q1 dash plus Q2 dash. This we know. So let's put this. C1 V1 plus C2 V2 is basically 40 plus 30, 70 microcoulombs. And here we have C1 plus C2 into V. C1 is 2 plus 3 into 10 to the power minus 6, and then we have final potential V, 7. So what you will get? Micro cancel. Sorry, this is 5. So 70 by 5. You have this is 40 plus 30. So V will be 70 by 5 volts. That is 14 volts. Okay. So the final potential is 14 volts. Now what will be the final charge? Let's see. Final potential is 14 volts. What will be Q1 dash? It will be C1, that is 2 into 10 to the power minus 6 into V, that is 14. So this comes to 28 microcoulombs. Obviously 40 to 28, that is there is a flow of 12 microcoulombs from first capacitor to second. Okay. So obviously if this is 12 has, this has reduced by 12 microcoulombs, so this will add to it. So this will become 42. Let's see. Q2 dash will be 3 microcoulombs into 14, that is 42 as expected. Okay, so we have found the first final V, Q on both, and now we'll have to find heat produced. What is heat produced? Heat produced is difference in potential energy. So heat is basically difference in potential energy, that is starting half C1 V square C1 was 2, sorry, 2. 2 into 10 to the power minus 6 into V square. So it is 400, 20 into 20 plus half into 3 into 10 square, 100. Okay. This is initial minus final. Half into C1 plus C2, that is 5 into 10 to the power minus 6 into V square, 14 into 14, 256. So you'll have to add these two and then subtract. So what you get is, it comes to 60 microjoules. It is energy, so joule. So this is the heat generated while transferring charge from first capacitor to second capacitor. Okay.